And thank you one more time to Neil and to everyone.
Hi everyone, it's Neil Hambly here. Good to be joining you on this Thursday evening. Well, it is for me. It's about 5 o'clock in the UK here. So fortunate I can kind of add this one onto the end of my working day. It's great to be able to come and do a presentation. The first one I'm going to actually do for the cloud data driven group. So look forward to doing this one. I haven't done this presentation for a while actually. The one I'm going to give you today is all about performance troubleshooting, kind of figuring out where your performance is maybe not doing exactly what you wanted to do. And we're going to be focusing on using SQL Server Dynamic Management Views, DMVs. So I'm going to do a bit of a presentation. I've got some slides that I'm actually taking from, as you may see on the screen here. Let me just kind of zoom in a little bit so you can actually see it. So from the Microsoft team, the SQL team, they have a number of SQL workshops. And part of that, one of the modules in there, module number 4, is actually all about performance. So I'm going to kind of focus a little bit today on this specific area here. We've got some slides that we're going to talk about through. The reason why I've done this one is because this link, you have access to it. I had a bunch of presentations I've done in the past around dynamic management views, and they're all kind of going back to about 2010. So way back when I was first started presenting, it's one of the first topics I actually kind of really got into presenting. And I've done it all the big conferences, SQL Pass. I've done it at SQL Bits a few times, and a few of the others. I've done pre-cons on this stuff. So the 1 hour or just under we're going to have today is going to just focus in on kind of the key steps, the kind of the essence of what we're trying to do when we look at that. And the tooling and the technologies that we have change all the time. So it's probably been about 2 years since I've really actually done this specific presentation. I do present a lot, and like last night, I was actually doing a delivery for the Open University in the UK. I had 240 students, all kind of having their first webinar for a 16-week kind of delivery that I'm doing around data skills. So that's kind of data fundamentals and some kind of data analyst type certification. But the SQL Server is kind of my background. I've come from working with SQL Server back in 6.5, back in the late 1990s. Yeah, I'm kind of an old geezer, as they say. Been around doing this for 20 plus years now, but I still have a great passion for kind of databases and data process, and I do a lot of training. I'm a Microsoft certified trainer, so I teach a lot of the Microsoft data kind of focus courses. That includes things like data science and AI and programming languages like Python, for example. But I do teach the SQL Server ones, not as much as I would like to, but because there's less demand for it than there is for some of the other courses. And the data engineering certifications, I will be doing a teach the trainer, TTT as they call it, for MCTs and MVPs. I'm also a data MVP as well. So today we're going to be focusing on doing this 04 module. I'll just kind of bring it up a little bit and kind of explain what we have here, why we're kind of focusing on this. So it's all about trying to kind of provide either for Azure SQL database, and the reason why I've got Azure today here, as opposed to SQL Server kind of boxed on premises. And to be honest, they're very, very similar in terms of the kind of approach you're going to take to actually performance tune, identify the problem area, figure out what options we have to try and kind of tackle that problem. So once we kind of know what the problem is, which is usually the first kind of part of the battle, is to identify where our problem lies. Is it a resource issue? Is it a coding issue? What's changed? You kind of go along, normally everything's good, and then one day you come in and it's like, my performance sucks, and it's like, well, we haven't done anything. But things change all the time. Data changes, statistics become stale, all these kind of different changes. So we want to be able to monitor our performance of our SQL Server engine and the underlying subsystems like the IO storage, for example. And we want to be able to kind of figure out where the problem is. And we're going to use a specific kind of approach called weights and queues. And And this is what we call a weight stats analysis normally. So mostly people focus on the kind of specific weights that they're getting in the system, and they don't really kind of look at the resourcing aspect of that. So the weights and queues is a kind of a two kind of facet approach, where you look at kind of not only what weights are being exposed by the engine, like why did it stop? What was it waiting for? Was it waiting for a lock to be released? Was it waiting for a CPU cycle to become available to jump on and do some work? But the queues is also kind of like how much other work is actually happening, and what's my kind of process for understanding that. So we use, for example, performance counters to get an understanding of all that information. So I'm going to show you some scripts today. I'm going to introduce you to, if you're not already aware, and I'm sure you probably are, and I was actually attending a session, a recording, or kind of an online session yesterday at 3 a.m. in my time. So 3 hours ago, from Glenn Berry, Mr. Dr. DMV. Glenn has an amazing array of dynamic management view queries that he's done for all the different versions of SQL from 2005 onwards. Includes SQL Azure database as well. So kind of the ones that we have. I do have a kind of a noise coming in the background. So let me just kind of just check the I just need to zone out a little bit and just check my side. I'm just going to make sure we hold on a sec, kind of get that back up. There we go. And let me go to the users and just make sure. So if you aren't muted, by the way, I see there's a couple of people that aren't muted. If you can mute, because there is a bit of background noise that I'm hearing that other people will hear as well. Now for questions, I will be stopping at a couple of points and just checking the chat window. And if you have a question, do put it into the chat window. But we're going to leave most of the questions to about a 5 to 7 minute kind of window right at the end of today's session. Okay, so get those in there. There's probably going to be quite a few questions, I suppose. There usually is when I do this session. So let's get into the presentation. I'm going to be sharing you a bunch of resources, links, etc., kind of things that will help you understand how to learn more about the kind of approach that we're looking at, etc. But let me go and bring up that presentation now. Let me just load that up and put that into the window. Okay. So this is starting in module 4. Remember, this is a full day SQL workshop from the SQL team. And we've jumped straight into module 4 because it's all about the performance. Now, there's a lot of content in here. So some of it's going to be really relevant to DMVs. Some of it's going to be kind of ancillary, kind of similar to the process you're going to take. When you try and look at performance, we need to understand what is it we're trying to figure out. Are we trying to figure out, somebody said, hey, the database is not performing very well, or somebody thinks that the performance capabilities need to be reviewed in order to maybe get more throughput. You know, hey, we need to get this thing kind of just processing more workload. So we're going to kind of start with a few slides, and we're going to jump into a few demos, and I'm going to kind of keep you updated as we go, and keep an eye on the time as well. Okay, so when we look at performance, there's a couple of things that we need to kind of be just mindful of. What are the capabilities of the service that you have provisioned? So think about SQL Server, you put it onto a piece of maybe a VM probably, or if it's in Azure, it's kind of actually hosted on some other kind of virtual machine, some instance of SQL. And that's got CPU, memory, IO, it's got all the kind of networking and all that kind of functionality. So it's got some capacity, it's got some throughput. We also were talking about kind of the structure of those databases. So what indexes exist? What other kind of technologies, such as maybe in-memory, OLTP, column store kind of capabilities may be in play right now, okay, as well. Do you have partitioning? One of the things actually I'm finding that partitioning and maybe compression, especially with standard edition of SQL Server 2016 SP1, introducing page compression where previously it was only an enterprise feature, you may find that some of your performance capabilities may be improved because when you bring a page in that is compressed into memory, it's in a compressed format. So you can put more of that data into your memory set. Okay. And we got additional functionality that has been kind of added to the PAS systems, etc., over time. And that is, things like intelligent performance, where we capture information. We're using things like query store, and we're using, kind of additional data capture, and we're using some AI technology to kind of figure out how do we do things better. Okay, so remember we got different versions of SQL. We got like standard edition, enterprise edition. Some of these have different capabilities in terms of performance, but generally kind of when we talk about Azure SQL, we're kind of looking at kind of a kind of fully fledged product that actually kind of is where most of the development happens first now, and then they kind of finally roll out all those additional changes into the box kind of version of that over time. When we look at performance tasks, what are we actually kind of referring to? Well, we're talking about configuring performance for maintenance. So do we have the right configuration? No. Where's the files? How many virtual log files do I have? What is a virtual log file? We're not going to go into all those big mechanics of what all of those are, because we'll be here for a long time, and we only have about 45 minutes probably left on the clock to right now. So I'm going to focus in on monitoring and troubleshooting performance. That kind of second item there, I'm going to focus in on this one right here. So this is what we want to understand, is like, how do I know if I've got performance issues? Good question. Especially if I raise the question, it's always a good question. We need baselines. We need to understand what is normal for our system. What's the throughput? What kind of throughput do we normally have? How long do things take? What is acceptable for our business requirements? Okay, so when I'm looking at troubleshoot performance, I'm trying to figure out, can I get within those SLAs, within the kind of the KPIs that I need that to be? If that's a second response time, then it's a second. But if it's not, if it's millisecond, I need to have that done in 2 milliseconds. Then I need the performance to be kind of a lot more highly performant, essentially. So I need to make sure my code's on point. I'm not using bad coding techniques. I'm not making lots of scans in my database. Everything's kind of like being done really efficiently. So the way we kind of figure out that a lot is by using what we call a query plan. And that's the understanding of all of the kind of steps that the engine and the storage system is actually going to undertake to retrieve and process that data. So we might be doing a query plan analysis, and we'll be using some of the DMVs that we're going to talk about and look at in a bit of more detail now, to bring that information back to us, to showcase that. And how do we do that? How do we kind of make use of these queries? Well, as I said, Glenn has an amazing set of queries. I'm going to show you where you can access those. And we can even kind of use things like Azure Data Studio and put those in notebooks, and use something like DBA tools to go and collect that data. There's some built-in functionality as well. We're talking about query store. We're talking about weight stats analysis and some reports that actually exist right now. So let's go and see what we have to share with you. So I'm not going to go through every slide in this section, by the way, because you will have access to look at all the slides. But I'm going to focus in on what's important for today's session. Okay. Indexes are going to be one of the key areas around performance. Can I get the data quick enough? Can I find the data? Can I process that data? So maybe I've got too many indexes. Maybe my indexes are not being utilized. You may have heard something called implicit conversion before. Implicit conversion means that we've got two different data types. Now, if I'm trying to search for something and I'm kind of trying to do a join, for example, on that column, and one is a kind of data type, say a numeric 10-0, and one's an integer, they essentially look like numbers when you look at them, but they're different. So you will have this implicit conversion. What that means is you don't get to use the index. So all these indexes you're maintaining and supporting and keeping up to date, they're going to have very little use. Now, we've got some great queries. They call it the bad person queries in Glenn's terms, where kind of you find which queries and which kind of store procedures and other kind of executions you're running are actually kind of not working very well because of things like code, like issues with saying implicit conversion. Okay, so we've got a focus maybe on indexes. We're going to have additional information, configuration settings, maybe just the overall volume of throughput you're actually trying to do, how many kind of transactions, how many connections you're running. Do you have enough resources there? What kind of balance between your read and write type of activities? How many writes are you doing in your system? Is it a heavy write operation kind of type database, or is it a heavy read, or is it kind of a nice balance there? And what kind of additional kind of functionality in terms of things like OLTP and memory optimized objects and all these kind of additional changes? And even going back to looking at things like compatibility levels, where we actually say, hey, you know what? This is a 2014 database, but we've never actually kind of moved the compatibility level up as we've gone to new versions. So as we go to really kind of 2016 and above, in terms of the engine, the kind of hot fixes and the performance characteristics that have kind of been added to the database engine as it's gone through different releases, they need to be kind of made available. And the compatibility level kind of allows you to kind of turn on what is the maybe cardinality type estimator that we're actually using, which version of that. That's going to improve performance maybe. And there's things like that. So we need to understand configuration. We need to understand throughput, how much data, how much memory you're using. What is the breakdown of your memory caches? If you've got lots of databases, as you're probably aware, kind of SQL servers are really hungry kind of database for memory. It kind of just gobbles up as much memory as it can get, and it doesn't like to let go of it. But you may have conditions that are memory pressure conditions. What that simply means is we're churning over that cache really, really fast. Why do we do that? Well, basically, if we don't have the data in memory that we need to process, we have to go to disk and kind of grab it from the actual data files and bring that in. And once it's in memory, we can actually process on it. But if we've got a lot of databases and we're sharing that kind of overall buffer pool, as it's known, cache of memory. So say it's a 64 gig deployed SQL Server, and about 58 gig of that is kind of the buffer pool, something of that nature. And you've got, say, 10 different databases on there, you're sharing that 58 gigs worth of data, okay? Now, one of those could be a really hungry kind of hippo in terms of trying to grab as much memory as it could. It might be starving some of the other databases, because what that means is we're having to kind of do this kind of data churn, constantly reading data in and moving some older data out. And we're kind of doing lots of reads and lots of kind of scans and filling up. Again, going back to that kind of compression statement earlier, where I said, if you were using either page or row compression, whichever version of SQL you have, that might improve the kind of the amount of memory you can help store inside of that. And we've got some examples of kind of looking at what is the on disk and in memory size of your indexes. Do you need that index? Does it actually provide you real value in terms of making that faster for the kind of the amount of space it's going to take? So all these DMVs that we have are going to be showcased in a moment, and we're going to show you a bunch of DMVs. There's so many more that we can show you today, but I want to kind of give you the high level kind of view into that. Okay, so we're not going to go into the rest of the stuff there again, kind of, but what we want to do is when we're going through and looking at performance, there's a few things that we need to be aware of kind of in terms of kind of configuration, like TempDB. That's your kind of scratch pad of where it kind of does overflows when your memory grants are not quite the size correctly. And that might be because you don't have the right amount of kind of statistics, or the kind of indexes are a little bit stale or something like that. So it kind of figures out, oh, I think we should be using these operators. And that's going to be a 4 meg execution. Great. But actually, when you go and run it, it needs 8 meg. And what happens is it overflows those buffers and dumps it all into TempDB. So lots of things like that. So we want to make sure that we have the right performance of the kind of files in TempDB, the right number. And there's a bunch of blog posts out there and information about how we do that, mixed extents, single page extents, etc. But we're going to kind of skip most of this today. We're going to go straight into the main thing for performance, which is your stats. Okay, so rebuilding, reorganizing your indexes, all very good. But if your stats are wrong and you don't keep your stats up to date, and you're kind of just relying on SQL to kind of do all of that work for you, and you're not keeping an eye on it, this could be an area that you are kind of just missing out on performance capabilities there. So we're going to focus on looking at stats, looking at the last time an index was used, when it was last updated, and these kind of things. We can run some queries using the DMVs, the database index DMVs, specifically to go and look at those details. Okay, and we'll look at query plans as well to understand some information about what type of operator. Is it a scan? Is it a seek? Is it a range scan? What is it we've got there? So we can look at query plans as well and use some tools. There's some free tools like the Plan Explorer from SQL Sentry that are just awesome at kind of providing a raft of information about the query plan and how well it's kind of working. So we will hopefully showcase a little bit of that. I'm not going to go through the knowledge check because this is something you will be going through, but basically kind of if you go through this this actual full workshop, you'll have some examples there. What I'm going to do is going to kind of quickly show you that though, at some point, you may just need to improve your hardware, i.e. more of it. The problem of how do we fix this? Well, we just throw hardware at it. That only scales so far, by the way. But I've seen many shops that run SQL and they don't have dedicated DBAs or people understand performance. So what do? They just kind of push the scale up and make it bigger. Hey, look, if the size that we have, let's say it's a 8-core, 128 gig RAM SQL, and it's kind of not doing the performance it needs because maybe it's kind of struggling a little bit on memory or CPU pressure. We'll just make it bigger. We'll make it a 24 core. We'll make it a 256 gig RAM. We'll get more memory kind of allocated. Okay, that's probably going to solve some of the problems, but it's probably not going to solve most of the problems you have. It's going to solve some of the issues. So throwing hardware sometimes is a way, but often you will also find that you can have like the I/O characteristics of the database, where it's located, and what type of performance. So when you provision, for example, Azure SQL, you have kind of a standard DTA, and you have kind of the normal kind of SQL, and you have a high performance version. You pay more for it, but the thing runs a lot faster. So virtual cores, number of kind of I/O channels and performance, and what versions of that. Yeah, you can kind of do that. But we can also make some maintenance on that stuff as well. So we can make sure that the indexes are just the right number, etc., etc. Okay. Now, ultimately, at the end of the day, what we're trying to do is we're trying to gather enough information from a kind of monitoring perspective to go in and quiz that database engine and go, okay, tell me what we need to do here. And that's where the Azure Monitor metrics and logs that you might have specific to Azure SQL, but for both SQL Server in Azure and SQL Server variants, all the different variants we have the dynamic management views. Actually, they're called dynamic management objects, and there's views and functions. Now, views are kind of that collated and stored information. So as the engine's doing stuff, it's kind of constantly reporting and storing in an internal engine, internal database that you don't get access to, all these kind of stats. We can just run that query. It's like a view and go, okay, we've got the DB IO, virtual file stats, for example, and we give the file ID number and the database number, and it gives me the results of that specific file, kind of performance characteristics, latency and that kind of stuff. But we also have DMFs. And some of those DMFs are heavier because we actually have to, at runtime, when we run the query, it has to go and do some additional data collection. So it kind of puts an extra load on the server. So we've got this kind of DMV, DMF kind of variant there. So just be aware kind of when you run these dynamic management views, they're kind of given a group name of DMVs. Some of those may be DMFs as well under the cover. We have recently, or say fairly recently, Query Store was introduced to help us understand when plan cache changes, i.e. a plan changes its kind of shape and design based on maybe the amount of data and other reasons, and even things like the connection properties of how you connect and which tools which libraries you're using to connect to it. The Query Store kind of tracks all these changes over time. And you may find you're going along and everything's good and the performance of the system's great, and then suddenly it kind of tanks on you, kind of just goes downhill. And we can go and look at the Query Store, and we can make sure that we need to turn that on, by the way, to every database that we want to monitor. By default, it's off. We can go and look at the Query Store and see if it's changed. And actually, then we can actually compare different plans. We can see what the plan change was. And we can maybe even revert to a previous one. We use things like plan guides and kind of switching back to use a specific plan ID that's actually a more performant one. So we've got capabilities. And we have a raft of additional kind of data capture through the, it used to be called Profiler, but it kind of changed many years ago now to extended events. So I'm from the extended events camp in terms of kind of how I want to understand all of that and capture all the information. And these are a much lighter weight kind of overhead for capturing information inside of the SQL Server. Let me just get the chat window back up because it disappeared. Hold on a sec. Just going to see if we have any questions at the moment. No questions. So if you do have questions, do put those in the chat window, and I will kind of check in on that every now and then. Let's get back to that presentation then. Okay. So this is what we're here for today. Okay. So all of the SQL Server DMVs are available. There's a few differences between the Azure SQL and the SQL Server on premises. Okay. Mainly because kind of there's an architectural difference in that you don't have control of kind of the file system and kind of some of those kind of controls around how it's hosted and stuff like that. So some of the common DMVs will be different or changed or not available. So for example, I'm not going to be able to kind of see certain DMVs that I would on an on-premises instance. I won't have access to some of those kind of file system capabilities inside of the Azure SQL. But ultimately, most of what you're going to do for your common DMVs will be across both of those SQL managed instance or SQL on premises or VMs and Azure SQL. Okay. So some of the key ones we want are, for example, the IO virtual file stats I mentioned earlier. What does that give us? Well, we're going to see an example of that in a minute. That tells us how well the performance of reading and writing to those actual files that have been kind of achieving. Now, with most DMVs, they're kind of accumulative. So they're since the last time SQL Server has started, or clearance of the weight stats themselves. Some are clearable, some aren't. And this will kind of give you a aggregate view of kind of changes. So what that means is we may have to take kind of snapshots and do deltas between those to get us kind of more real time. But what we have found is that up into I think kind of 2019 or just before, we only had kind of instance level weight stats, which means we kind of look at the whole instance of SQL and all the databases on that. But what we introduced was then something called session level weight stats. Session level weight stats kind of are for the specific kind of connection. SPID number 58, for example, I can look at the stats that are generated from that connection during the life cycle of that connection. So I can kind of zone in on specific kind of queries that are running, for example. So we've got instance level stats, what's mostly what we're looking at. And we may take deltas and kind of time points and analyze that. But we also have session level stats that have come in more recently as well. Okay. If you want to get into real detail, I mean, you may have heard something called SQL Cruise. We stopped doing this a few years ago, obviously because of COVID and everything else. But you know, back in the day, I think kind of probably 7 or 8 years ago, I did a session on one of the SQL Cruises, and I just did 2 hours on memory clerks, DMVs, and the details of how we can analyze that and understand the throughput of memory buffers and this kind of descriptors and stuff like that. So you can geek out on this stuff. I know I have, but I probably would struggle even now today. I haven't done it for a while to kind of remember all the mechanics of that. So, but you have a lot of information that you can go and delve into. Okay, so great. We will kind of so extended events will help us kind of find some of the information. And one of the ones I'm going to focus in on there is something called a ring buffer. This is kind of a circular set of buffers, memory buffers that we can kind of do. And the ring buffer, for example, will give me the ability to see what's happened for, say, the last hour of data going through, say, CPU, for example. So I have lots of details I can capture, and these are coming from the DMVs, but they're being captured into the extended event sessions, for example. Okay. There's also some built-in session health and performance characteristic ones as well. And with Azure SQL and Azure Managed Instance, they're essentially very similar kind of sections that we can create, and we can define those, and we can make changes to these kind of monitoring kind of collection agents as they're going. Whereas profile of very before kind of that, we'd have to stop. We may miss a bunch of events and things that were kind of important, and we'd have to stop and start that. Extended events, we can kind of make those changes to what we're capturing and filter in and have related information captured as well, which is really good. This is the main thing I want to show you, really, because it's all about, are we running code? Because if we're not running code and we're not running processing data, we're just sitting there waiting for that kind of to be completed. Okay, so we need to be running on that CPU. But the way that the engine is architectured in a kind of cooperative kind of way is that you get a what's called a quantum. You get like a 4 nanosecond kind of amount of time on the CPU kind of cycles, and it does some work, and then if it hasn't finished, it may step off, let somebody else come and have a go, and kind of go in through the cycle of kind of waiting and queuing for CPU. If you get a lot of requests and you're constantly kind of waiting for CPU time all the time, we call that CPU pressure. And there's some queries we can run to identify, do you have that problem? And if you do, there's probably a fairly easy fix for that, because if you've got a 2-core CPU and you've got memory pressure, you can go up to a 4-core. You can give it more CPU. You can make maybe the CPUs themselves better. Think about your database hardware. Is it a year old? Is it 5 years old? Think about CPUs and the performance characteristics. And CPUs generally jump up a lot of performance to kind of every kind of couple of years generally. So if you've got something even 4 or 6 years old, the performance characteristics of that CPU family and engine CPU can be 30, 40, 50% less than kind of the newest CPUs. Okay, one of the advantages we have with Azure SQL is that we can kind of go, you know what, I want to use this family of CPUs. I want to have this many. And if you buy hardware, as I used to do in the day, and kind of provision it and put it in my own kind of data centers, etc., and 2 or 3, 4 years later, we still had that same specific CPU, and kind of we couldn't just swap it out for another one easily. Whereas with Azure kind of SQL and Azure itself, we can kind of like, you know what, I want to change that. And we have memory intensive configurations. We have better memory stroke CPU kind of balancing rates as well. But the performance comes from the waiting, or that's where your problem is, the blue wait stats, DM OS wait stats, DM exec requests, OS waiting tasks. We want to run these DMVs, and we want to see what does it give us? Now, as I remember, I told you saying kind of it's a kind of incremental. So when we do weight stats, we get a set of values for all the weight stats that have been kind of had actions on them, and it counts up. If we wait 5 minutes and do that same DMV query, the numbers would have increased. So this is when we do kind of a capture of some values, wait a period of time, capture again, and then do a delta between those. And that's actually the specific weights that we've encountered for all the transactions that have happened in that time frame. Remember, we also now have session weight stats, so that's going to make that a little bit easier to kind of figure in what they are, but it depends on the version of SQL that you are running, whether you have session weight stats available for you. Exec requests is what's running now. Cool. What am I waiting on? What resources, what objects, what indexes, what kind of tables, what kind of what locks are being kind of, so all of these details are kind of fleshed out inside of the exec request DMV, for example. But it's constantly changing. You run it now, you get a set of values, you run it a second later, you get a different set of values. So things like the who is active SP from Adam McCanny was a great one at kind of giving you that high level kind of view and kind of making sense of the data that comes from these different DMVs there. Okay. We're going to look at Glenn Berry's DMVs in a very short minute. Okay. So I'm not going to go into any of these values because we just don't have time, and I've gone through a lot. But basically, this is kind of what we need to do in terms of performance tuning the server. Is we need to figure out what is the problem. Is it a CPU problem? Is it an IO problem? Is it a code contention problem? What is the issue? Where is the issue? So, there's certain ways we can improve the performance of the system by configuration, making it bigger, etc. And maybe using some new functionality like column store versus row store kind of deployments. But what we want to do is we need to figure out kind of what is our typical workload, and then we're going to kind of figure out, okay, what is kind of additional capabilities inside the engine that allows us to do that. So, for example, we call it the intelligent query processor, where it kind of takes a lot of this information and figures out how to do things. Remember, we're talking about compatibility mode here and maybe jumping up a couple of levels there. Okay. Okay, I think it's time for looking at a few queries here because I've got a lot more here to show you, but we kind of we'll spend all our time just going through these slides otherwise. One of the things I do want to make you aware of, kind of zoning a little bit here, is if you're doing something like SQL Server and Azure SQL Database, you do have some kind of query insight, and it goes and kind of showcases a lot of this information right on your doorstep. Straight out of the gate. There you go. Just click on it and just go in and look at resource consuming queries. You can break it down by CPU, data, log, and you can see the queries, and you can even kind of come in and see like how long things were running, etc. You can see obviously query ID 121, 71%. That's probably one I want to have a look at. Okay, and then I can go and look at kind of more details. And there's also some recommendations that might go, you know what, hey, we think you should probably create that index. So missing index stats and DMVs and all those kind of things there. Okay. So I'm not going to go through the knowledge check. We're going to click through that, but basically I'm going to go and show you the DMVs now and show you some of the queries. So let me escape out of that for a second. I'm going to bring over. Actually, let me just do that first. Let me go and bring up this one here. Okay, so. And I'll give you the links at the end of this. I'm going to put some links into the window. So Glenn Berry has his diagnostic information queries that he's been producing for a long, long time. And you can see here we go all the way back to 2005. And he updates these. I think the last update was a couple of weeks ago for October. From 2005 to 2016, SP2. These are legacy. And then we have the current kind of on-premises 2017 and 2019 SQL, as well as the Azure versions of that, so the managed instance, etc. But what I'm going to do is I'm going to scroll down, keep going, and we come down to some queries. He's actually kind of some videos he's put together around a lot of these the queries in kind of different parts. You can see there's 14 parts there, lots of queries there. But in here, we have, and I think I've got it here, let's say, what's up? Bring it up. We have some notebooks, and the notebooks are generated. You can go to a link I'll give you, where it's the Azure SQL Database Diagnostic kind of, it's a notebook that's been created for the Azure SQL. You can see here, this is the database I'm currently connected to. It's in database.windows.net, and in here we've got a few tables, and so this is just an example of that. And what I can do, you can also kind of go and manage and bring up say that specific database. I can go and look at the server reports and see how well this thing is kind of running from a weights perspective. So this is some of the weight stats analysis that Paul Randall from SQL Skills put together and made. They made an extension for the Azure Data Studio here. So, for example, the SOS Work Dispatcher, that's actually kind of one of those benign weights that you just want to ignore, because in Azure SQL, kind of it's just sitting there kind of looking for things to do. It's like, have I got anything to do? Anything to do? So this server doesn't really do anything apart from like once or twice a day. But we will have weights that will kind of be visioned up. And also some of the other things is how much buffer percentage is that database using compared to the other databases. And you can see that resource database. Guess where the DMVs sit? Over there. Okay. So this is kind of a quick breakdown. This is one of the extensions that I've installed called Server Reports. And it's kind of I think, let me go and look at the details. Yeah, so Server Reports from Microsoft. And you can kind of, let's go back to where I was. There we go. So I can run these queries. Now, because it's a notebook, I have a huge amount of additional information I can share. And one of the other things I can do is I can also kind of do it's probably not a great one. Let's go to this one here and do this report here. Again, not the one I was looking for. This one is this one. So let me go and just minimize a couple of these just to kind of so not only am I getting the information back, there we go. I can also see exactly kind of what the queries are and kind of understand the plan. I can look at the query. I can look at kind of additional information when it was last compiled, etc. So I'm going through a lot of information about these different plans, and also, let me kind of do a quick review of that and do that by not the one I wanted. Where's the one I want? There we are, optimize CPU time. So I'm kind of looking at how much time it takes to kind of optimize and going to look at specific queries. And I'm using this Sandance kind of visual to kind of give me a breakdown of the information. I can capture this. I've got my query plan hash and IDs. I've got my information that I can see. It's a simple parameterization. When it was last compiled, so much information is being kind of showcased here in this specific. Bring it back and bring it into view. There we go. So I can spend my time, but I can also go and filter and search for specific query IDs or kind of go through them one at a time. Look at those individually. And let's see if there's anything I've sent here. So here I've got one that is kind of probably a little bit more interesting, and I've got my batch handle, and what I could do is go and look at that and actually look at all of the kind of characteristics of that SQL plan there. Okay, so there's tons of information to share here. Let's kind of get rid of a couple of these for a second. So we don't need all of those up there. Don't need to save that one, but this is the notebook, and we go through, we can see all these different kind of queries that are running here. So for example, this one's giving me my kind of memory analysis. So I've run that query. Oops, I need to choose the database. and it's run. And I'll tell you what, I needed to just recheck that. So I think we did that slightly wrong. 1 second, let's change connection. Change that one to there. Connect. Okay. So I often find this kind of gives me a problem sometimes. So when I run it earlier, not a problem. You can see here, it ran, it did me my kind of analysis. These are examples. This is one that probably would help. This is going to show me IO per database. So I can actually kind of just go into configure that chart, and I'm going to do the kind of name of the databases or the ID of the database that is actually kind of then you see clearly that for this one, number one, we've got a lot more IO coming through from this one, read mostly as opposed to write. So there's the balance there. And I keep going through and I'm doing my analysis on how many pages are actually in the buffer pool. So again, I could do some kind of reviews in terms of how it looks and how this is kind of ranked. Lots of queries that I can kind of run. So if I go into, so there won't be anything on blocking. We want to go into, say, this one here. 1384 meg, so 1,385 megs worth of memory, memory being used for the SQL CP versus the SQL buffer pool of 570. So the majority of the memory, actually kind of nearly a 3-to-1 ratio here, is actually the cache plans. Okay, so the cache store, SQL CP, that's the cache plans. It's spending of the total memory I have on this configuration, it's spending nearly 1.4 meg of cache plans. I guarantee you there'll be a whole bunch of ad hoc SQLs in here. So these are the SQL, these are the DMVs that we're running. And the DMVs are essentially a whole bunch of DMVs like this, okay? So let me go and show you what that set of DMVs is. So let me go and where we want to go to here. Nope. Let me go find the DMVs. I had it earlier and I closed it out by mistake. What did I do with that DMV list? I think it's here. So let me open up. Let's do this actually. DMV. There we are. Monitor using DMVs. There we go. Okay. So we have a whole bunch of different DMVs. And here's the name of the DMV. So performance counters is actually another DMV. We actually can expose all performance counters out there with that as well. Okay, zone in. I see this coming up a little bit. So can we share the codes, please? I'm not sure what codes. So the if you're talking about the dynamic management views,
you can email them to me and I will share it with it.
Yeah.
With
so
everyone.
This is the SQL. This is where you want to go to. You want to go to Glenn's SQL Server Performance, and all of his resources are essentially these dynamic management queries. And you go. So if I go and show you this, let me go and grab the Jupyter Notebook version of that. I'm going to go and click on this one here. Going to download that file. Let me just go grab that file. Again, let's wait for that to download. And then I'm going to open up my connection. This is going to go open. So file, open. I'm going to go grab that from my download folder. And I've got, there we are, the diagnostic query there. Okay. So this has opened up, we'll do in a second. I don't know why it does that. It always takes a little while to come up. Here's all the diagnostic management queries. And it explains when it was last updated, it explains kind of more about kind of understanding. But you can see here, if I actually run this query. So for some reason, I don't know why this is, I've something going on with my connection because it was working earlier. But if I want to come down, I've got all the different DMVs in there. Now we can also go to, let's kind of bring over SQL Server Management Studio, because this is an example of a dynamic management view that's kind of a little bit more involved, where we kind of are setting some variables. But then what we're looking at the query store DMVs. And we're going to get the run stats and stuff. We'll run that. Sorry, wrong. Query store, this is the one I was looking at. If I look at the DMVs that are going to expose what is the query ID. 1 second. It's showing me the query text. It's showing me, kind of hover over that again now. It's showing me the query text. It's showing me the amount of time in CPU time, how many times it's been executed, what was the kind of recent execution time, what was the historical one. And I got my query plan here. And what I could also do is I could go and look at the query plan, and I can go and understand the details of that query plan, which indexes are being used, what kind of operation there. So we're using the query store to kind of take the plan cache and bring that out and showcase this in maybe the query store or the comparison. But this is where the wait stats comes into play. If I just highlight, so let me just do this wait stat CPU. I can see the types of waits that we are having. I can see kind of how much wait time. So obviously, nothing really to speak of here, of course. But if I had a very high wait time in the thousands, so minutes and seconds, or seconds and minutes of time, then this is something I would probably want to investigate. This one's clearly not a problem whatsoever, but I've got this one here. It's a little bit more advanced. But again, you can see here, we don't have a lot of time with that, but the query plan itself is a little bit more involved in terms of it's got scans, it's got table value functions, it's got a lot of code going on. And if I look at kind of the actual query itself, it's very advanced. So we would do an analysis on that. We will find queries that have high variances in terms of the amount of time it takes to run. So sometimes it's taking maybe like 4 milliseconds. Other times it might be taking 400 milliseconds. It might be doing that 100 times a difference in terms of performance. And we got lots of differences here, but what we're trying to do here, we're trying to do analysis, and we use that with the query store based in which you can turn on very easily and then do that analysis there. So again, all of this information comes from, I'll open this one up, comes from the query stats. And the DMV OS wait stats is the dynamic management view name for that. There's an internal and external version of that. But what we're doing is we're taking a lot of this information and showcasing it in tools like the SQL Server Management Studio and tools like Azure Data Studio, but also tools that we probably want to be having a quick look at. And if you're not aware of them, you just go and grab those quickly. They are, let's add the next one up and just grab the, where is the Century one, if I can find it. Can't see it there. Okay.
I can share that link with
you.
As
so
well.
Anyway, there's a tool called the so here's examples of some of the DMVs and dynamic SQL they're using as well. But you're seeing that they've got some complicated queries that are being run against exact query memory grants, session exec stats. They're running these queries and they're getting lots of information. So there's so much information out there. What you need to do is you need to probably use a tool like SQL Sentry Plan Explorer. You want to use something like one of the monitoring tools from Redgate or SQL Sentry or Quest or whichever product and owner of those tools that exist there, because they constantly buying each other, I think, all the time. These are examples. When you run that query, you'll be seeing, if you go right down into here, it's actually even going to the point where you're running and getting the SQL text of the query that's being run, and it's extracting that and finding that information and doing an analysis on that and giving us back the whole query plans and etc. So if I wanted to take that specific query and run that, I get a full breakdown of what's happening right now on my servers. Okay, I know we kind of pretty much out time. There's really kind of so much to kind of try and share with you, but what I try to do right at kind of the top of the hours is basically say, look, hey, if you're going to kind of want to do, let me go to this for a second, is there's a whole bunch of training from the data exposed team. You go to the videos, there's like about 200 of them, and they really kind of get you into kind of things like what is the capabilities of these services, like the insights, where it kind of provides you with a breakdown of how your services are running, what data does it collect. And if you can see around here, there's going to be a whole bunch of DMVs that are going to be included by default, like the awareness weight stats and the database weight stats. This is the kind of session, these are the data Azure version, and they are kind of just really fantastic amount of information being shared. But I would say go and look at Glenberry's DMVs, go and grab the relevant version. There's also an Excel file you can kind of paste your stuff into for viewing, and just kind of start looking at what's there. But remember, you're not going to kind of probably fix everything with just one kind of, just looking at weight stats isn't going to do the job. Look at that, look at your baselines, look at the other information, but figure out what's going on. Okay, so that is the essence of what we're trying to showcase today. Unfortunately, an hour never does it justice, and I know we're pretty much literally on that hour of time. So with that said, what questions do we have, if any?
By the way, that was an excellent presentation. Thank you so much. I even learned so much from your session. If any one of you happen to have a questions, raise your hand and we're gonna do that in order.
I think they all fell asleep.
I don't think so. I think you probably did a good job. I don't think you.
I see a few names there. David Stokes is on the call. Lots of first names, so I can't tell. So what I will do, so I will provide. So say you can see here, I have my collection, which literally has so much information, kind of notes and stuff I do as I do all my different kind of my trainings. I have all of these different kind of training programs and stuff. So this one here was I will generate a I'm going to see if we have it here. Can I send it to Word? I'm just going to send it to Word, and whether we can actually paste that in. Let's have a quick look. One sec. So here's the links, and if I just grab all of those. So there's a lot of information here. So I don't know if I can. I'll try and put the links in. So there's a absolute ton of links there for you. Hopefully that just they're not in any specific order, by the way. It's kind of like just the things I kind of use. For example, this one here. We click on this link here. It's going to take you to a video with the Perf Insights capability, and if I scroll across a few kind of thing, it takes you into, I think, kind of things about kind of, okay, let's look at CPU, let's look at memory, network, SQL, kind of here's the references, and there's just a vast amount of data and things like that. So there's a ton of links there for you guys, and hopefully then you can kind of start using these different kind of graphs and views into figuring out exactly what kind of is going on with your systems and collecting data with the diagnostic tools and stuff. Cool.
Guys, if you have any questions, feel free to raise your hand or unmute yourself. I know you did a great job, Neil. You probably didn't leave room for questions.
I never leave room for questions. I always run out of time. This is when you come to the end and people walk up to the podium where you are, and you just spend an hour talking to people about it for all the questions that they have.
Right.
Oh, look, I've put my hand up. I've got one question. Is hopefully this was enjoyable for everyone. Hopefully there was a little bit of knowledge being shared there, and maybe an interest to go and kind of figure out a little bit more of this weight stats kind of capabilities, and check out your systems. Are you doing a regular weight stats analysis? If not, maybe it's time to start that process. But I'm going to thank you very much for the opportunity to come and talk to you guys today. It's an absolute pleasure to do that, and I'll maybe hopefully try and do it another time soon as well.
And you will, especially you mentioned something about Python. Actually, I'm preparing a session regarding Python for the DBAs. If you want, I can keep you in the loop and schedule you, to do something similar like that.
Okay, yeah, please do. And if you, I'm just going to put my LinkedIn. So if you have questions, by the way, you can kind of get me on LinkedIn and also our friends, Mr. Twitter. So I've got about 4,000 crazy people following on both of those. So let me kind of just click on Twitter as well. And you, by all means, kind of hit me up on either of those platforms. And cool. And I do have a YouTube channel as well, which I haven't done anything on for like ever. But I'm just going to go to my Data Train YouTube channel and actually just kind of do Data Train. I think is the so there's a whole bunch of videos, mostly around Power BI at the moment and there, but I've got to do a whole bunch of new videos. So feel free to kind of hit me up on my YouTube channel as well. There will be SQL content coming to this sooner than later. I've got a bit on there at the moment. Mostly it's on kind of Power BI and data science stuff as well. But there is the occasional have a session as well on there. Some of my conference ones as well that I've done, and some of the exams that there's around there. Cool.